Okay, so that was question number 1 on this sheet 5. Let's look at question number 2. Question number 2 says a squared minus 14a plus 45 over a squared minus 81. And again, it says simplify the rational expression. So again, since these are polynomials in both numerator and denominator, we've got to factor as much as we possibly can. Again, this is not the difficult type of factoring because we're starting with just a plain a squared, so I can break it up into a and a. Again, I look at my final term is positive, which means both signs are the same. Looking at the middle is negative means both signs are going to be negative. And I'm looking for two numbers that multiply to 45, but when we add them, give me 14. And I think everybody might realize it's 9 and 5. 9 and 5 add up to 14. So I'm going to put a 9 and a 5. And it doesn't matter which you put first, the 9 or the 5, because these both have minuses. The denominator happens to be a binomial, which is the difference of perfect squares. It's a squared, which is a, and it's 81, which is 9 and 9, and there's a minus in between them, so I can break it up into the two conjugate binomials, the a plus 9 and the a minus 9. Now that I've completed my factoring, I can look for like factors. A minus 9 on top. Well, on the bottom, there is an a minus 9. Don't make the mistake. A plus 9 and a minus 9 are not at all alike. They cannot cancel each other out. The only thing that doesn't have to be identical is if the order switched. Not if the sign switched, but if the order. In other words, if there was instead of an a minus 9, there was a 9 minus a, we could use it. Remember, in that case, you'd have to put a -1 in place of 1. But these are both a minus 9. I can cancel out. The a minus 5, there's nothing to cancel with. So my final answer becomes a minus 5 over a plus 9. Okay, does anybody have any questions on any of these that we've done? Okay, so then I'm going to go on to question number 3. I'm going to erase this and go on to question number 3. Number 3 looks like this. It says, perform the indicated operation and simplify. We have an x minus 2 over 5x plus 7y. And then it has a times sign. And the next fraction is 25x squared minus 49y squared all over x squared minus 9x plus 14. And if you recall, this is a multiplication. Sometimes they just use a dot. Sometimes they just put the two fractions right next to each other. Because remember, when there's no sign in between to a letter and a number or two letters, it means that they're being multiplied. And again, what we have to do in this case is totally factor everything. Now, x minus 2 is already in its most factored form. There's no way you can simplify that. Similarly with the 5x plus 7y, it cannot be factored any further. So let's go to the 25x squared minus 49y squared. That is the difference of squares. 25x squared is 5x times 5x. 49y squared is 7y times 7y. I'm just going to write this on top. So I can write it. Remember, this gives us conjugate binomials. 5x plus 7y and 5x minus 7y. Now I'm going to put a line through this because I'm not totally, I want to be able to see what's underneath there, but I'm putting a line through it so I know that I'm working with the factored form now. Otherwise, it can get the biggest problem is if you don't do it neatly, that you can mess up because you won't remember what was there and what wasn't, and it's scribbled up. So don't scribble it a single line or two, and then the new thing written on top. This also has to be factored, and it's x squared. We're going to break up into x and x. The final term is positive, means both numbers have to have the same sign. The middle means they're both going to be negatives. And we need numbers that multiply to 14, but when we add them, they give us 9. That's obviously 2 and 7. Okay, so I am going to put a line through this also. So this is what I'm using now. I factored everything as much as I can. Now, remember what I do. I look to see if there's any factor in the numerator that can be canceled out with a factor in the denominator. It has to be a numerator with a denominator. It can't be two numerators. It can't be two denominators. It has to be a numerator with a denominator. And I see an x minus 2 here and an x minus 2 here. So that can cancel out. Notice there's nothing left in this fraction, so I'm going to put a 1 there to remind myself that I factored by division, which means that my result is 1. I then go, that takes care of this numerator, go across. I always like to go across the tops. The next thing I see is a 5x plus 7y. And there actually is a 5x plus 7y in the denominator, so I can cancel that out with that. Notice I'm going to put a 1 here as well because there's nothing left over here, and I don't want it to look like there's a 0 there. There is a number. You cancel that by division, it leaves you 1. The 5x minus 7y, there's nothing to cancel with it, nothing to cancel with the x minus 7. So your final answer, if we look across the top, is 5x minus 7y in the numerator and x minus 7 in the denominator. And that would be your answer to this problem. Looking at question number 4, I'm going to start. I hope I'm going to have enough room over here. Question number 4 is 2x minus 3 over x squared minus 10x plus 25. And again, this is times x squared minus 25 over 10x minus 15. Again, this is a multiplication. So again, we have to, and these are all polynomials, so we have to factor 2x minus 3. There's nothing to factor there. It's as simple as possible. There's no common factor, not the difference of squares. This, we can factor to x and x. My final term is positive, and the middle is negative, means both of them are going to be minuses. And numbers that multiply to 25 and add to 10 are obviously 5 and 5. Let's put a line through this. Of course, you could have written it as x minus 5 with a exponent of 2 on the outside, but it's better to leave it separate when you want to see what you can cancel out. Now over here we have x squared minus 25. So that is, again, our difference of squares. That's going to be x plus 5 and x minus 5. Cross that out. And this is 10x minus 15. And remember, I'm always looking for a common factor first. I didn't mention it before because I didn't see any. But here there is a common factor of 5. And 5 into 10x is 2x. And 5 into negative 15 is negative 3. Okay, so now I totally factored everything that I have here. Let's see what we're left with. First of all, there's a 2x minus 3 in this numerator that will cancel out with a 2x minus 3 in the denominator over here. Again, this becomes 1 because everything's gone from there. Here's an x plus 5. Is there any x plus 5 in the denominator? Remember, I can only cancel it out with an x plus 5 or possibly a 5 plus x. It can't be a different sign. It could be just a different order. Since there's nothing like that, I go to the next one. Here's an x minus 5 that I can cancel out with one of these. It doesn't cancel out with both of them. It cancels out with just one of them. Now let's see what we're left with. On the top, I have a 1 and an x plus 5, which just gives me x plus 5. And in the bottom, I have an x minus 5 and a 5. I usually put this single term, the monomial, first. That's usually just the order that we put them in. It doesn't make a difference. You could have put it second. And here would be your answer. If you had wanted to, you could have multiplied these two out. In other words, you could have also said that this is x plus 5 over 5x minus 25. That would also be considered a correct answer, but I actually prefer this form rather than this form because if something is factored, you should leave it in the factored form. But again, if you're looking at this as a multiple choice question, which you'll have on the final, remember this is not on the midterm, it might give you this answer rather than this answer. Are there any questions on these? Okay, and I'm going to go on. We have 2 more to do here. Number 5 looks like this. We have x over x squared minus 25 divide by 5x over x plus 5. Now this happens to be the division of 2 fractions. And when you're dividing fractions, really all you have to do is, that's different than multiplication, is first take the reciprocal of your second fraction. Your second fraction is your divisor, and you have to take the reciprocal, you have to turn it upside down of the divisor, and then you multiply. So then this becomes x over x squared minus 25. Remember, the first fraction we leave alone. And we change it to a times x plus 5 over 5x. And then we look if there's any factoring we could do, because now we're doing the operation of multiplication. And x we leave alone, but the x squared minus 5 becomes x plus 5. And x minus 5. And that's all the factoring we can do. And now we are going to try and cancel. Now the first thing I see on the top is an x, a plain x. That is a single term. I can only cancel out a single term, a monomial, with another monomial. And the monomial I see in the bottom is 5x. Which means it's 5 times x. So the x over here can cancel out into the 5x and leave this a 5. So over here, we're left with a 1 because x totally canceled out. The 5x becomes 5 because this really means 5 times x. The x's are canceling out. Then I go to the next numerator I see, which is x plus 5. And I see I can cancel out the x plus 5 with an x plus 5. Remember, again, this leaves me a 1 on the top. I always must put a 1 where everything is canceled out. And now I multiply the two numerators together. 1 times 1 is 1. And the two denominators I have are the 5 and the x minus 5. Again, if you wanted to, this could be multiplied to 5x minus 25, but I prefer leaving it in this format. And the last question that I had asked you to do, number 6, is, again, it says, perform the indicated operation, x squared minus 9 over x squared minus 10x plus 24. Again, it's a division divided by x plus 3 over 2x minus 12. And just as we did before, the first thing we're going to do, since this is a division problem, is we're going to take the reciprocal of the denominator. And what I'm going to do is I'm going to do factoring as I go along, because I'm going to have to factor everything also. So this is going to become x plus 3 and x minus 3, because it's the difference of squareds, x squared minus 9. The x squared minus 10x minus 24, let's see what that can factor into. Obviously, it's x and x. Again, the last term being positive means both sides are the same, and the middle means they're both going to be negatives. And we need numbers that multiply to 24, but when we add them, they give us 10. And that obviously has to be 6 and 4. Now this becomes a times, and now the 2x minus 12 is on top. Now 2x minus 12 can factor into 2 and x minus 6. Remember, I'm making this my numerator, this is my denominator. The x plus 3 goes on the bottom, there's no factoring on that one. And now let's see what we can cancel out. An x plus 3 here with an x plus 3 here. Put a 1 here because everything's gone. X minus 3, nothing to cancel with. X minus 2, there's nothing to cancel out the 2 because the only thing I could cancel out the 2, which is a monomial, is another monomial, which there isn't. But the x minus 6 here can cancel out with the x minus 6. And if I look what I'm left with on the top, I have an x minus 3 and a 2. So I put a 2, x minus 3. Again, I could have put the 2 second. Usually the standard format is to put the monomials first and the polynomials second. So that's what I'm doing. And the bottom, all I have is an x minus 4. Don't make the mistake of like trying to cancel this 2 with this 4. This 4 is part of the x minus 4 that cannot be taken apart. The only thing that can be taken apart are monomials. Polynomials cannot. They have to be totally, each parenthesis treated as a unit. And that pretty much takes us to where we had left off on Thursday. Does anybody want to ask me any questions before I go on? Okay, so then I would like to talk about how do we add and subtract fractions? What is the method that's used for combining fractions by either addition or subtraction? I'm going to erase this, and I'm going to go on to that section. I'm going to start this by reminding you how to add fractions. What are the rules involved in just regular number fractions? Let's say I'll start with something easy. Suppose I had 2/9 plus 4/9. And I wanted to add these two fractions. And the two fractions happen to have the same denominator. It's called the common denominator. They're the same denominator. What you do is, when you're adding or subtracting of fractions, you don't do any canceling out of numerators with denominators. That's only left for the end. What you do is you make sure you have a common denominator. You have the same denominator for both fractions. And then you add or subtract your numerators depending on whether the operation says plus or minus. In this case, it says plus. So I add the 2 plus 4, which gives me 6. And I put my answer over the common denominator. So the answer becomes 6/9. That is the rule. You must have the same denominator, otherwise it's like adding like terms. Remember, you can only add like terms, you can't add unlike terms, you can't add things that of x with a y. The same thing with fractions, you can only add like fractions. That means fractions with the same common denominator. What you do at the end, after you finish your addition, which we did by doing 6/9, you see if you can reduce your fraction. In this case, this could be reduced because there's a common factor of 3 in the numerator and the denominator. 6 divided by 3 is 2. 9 divided by 3 is 3. So my final answer in simplest form is 2/3. If you're not told to put it in simplest form, or you're not told to reduce, you could leave the answer 6/9, but most cases they do want the answer in simplest form. Now, what happens if you have two fractions that don't have the same denominator? What if you had something like this? 2/9 plus 5/6. And you wanted to add these two fractions. Well, as they stand, you cannot add them because they do not have a common denominator. So the first thing you have to do is try and find what's called the LCD, the least common denominator. Now, there's a number of different ways this could be done. I'm going to show you a method that is maybe not the easiest when it comes to just numbers, but actually if you have a decent calculator, you could just do this on your calculator. We're looking for this as a method to use in our rational expressions when we have algebraic fractions. So I want to do a different method. What I do is I factor out my denominators. What does that mean? Well, 9 can be written as 3 times 3. And 6 could be written as 2 times 3. Factor your denominators. And then go to your first fraction, circle or check off, or just look at. I'm going to do it in the beginning by circling all the different factors from the first denominator, which are a 3 and a 3. I know the 3's are not different, but there are 2 of them, so I have to multiply. I have to multiply everything in the first fraction. Then go to the second fraction and look at your factors of your denominators there. One factor I see is a 2. I don't see any 2 circled here, so I circle it. Then I go to the next one. It's a 3. Actually, I've already circled 3s. I've even circled 2 of them, but I only had to circle 1 of them. Since this 3 is already circled, I don't have to circle it again. I have now circled all the different factors of the denominator. Take those numbers, the 3, and the 2, and multiply them together. 3 times 3 is 9, times 2 is 18. 18 is your LCD. Your least common denominator is 18. The next step after that, if you'll recall, is you have to rewrite your fractions with that LCD as their denominator. I want to rewrite 2 over 9 as a fraction whose denominator is 18. I also want to write 5 over 6 as a fraction whose denominator is 18. How do I do that? Well, I know a fraction remains the same value if whatever I've multiplied my denominator by, I've multiplied the numerator by the same exact number. So I started out with this denominator being 9. 9 into 18, I'm going to just put it over here, is 2. I multiplied this 9 by 2 to get 18. So therefore, the 2 over here, the 2 in the numerator, has to be multiplied by that 2 as well. So that gives me 4 over 18. If you think about it, 4 over 18 and 2 over 9 are the same value. This is the reduced value of 4 over 18. But we want to get this not reduced because we want to make sure the two fractions have the same denominator. I then do the same thing I did with my first fraction. I take the 6 from this denominator and divide it into the 18 to see what I multiplied by. And obviously I multiplied by 3. Since I multiplied the denominator by 3, I've got to multiply the numerator by 3. 3 times 5 is 15. Again, 15 over 18 is the same as 5 over 6. And now my two fractions have the same common denominator. So I do as I did before. I add the two numerators, 4 and 19, 15 is 19, and put it over the common denominator of 18. Notice I don't multiply the denominators together. Once I have a common denominator, that is the denominator that goes in my answer. I then look if this could be reduced. Notice, in this case, my numerator happens to be greater than my denominator. We sometimes call that an improper fraction, but for our purposes, we like to leave our answers like that. Don't change it to a mixed number, just leave your answer 19 over 18. So we now have the basics as to how to add, and if this would have been a minus sign, same exact steps. We need a common denominator, but instead of adding the denominators, we have to, adding the numerators, we have to subtract them. But again, it's basically the same concept. Okay, let's see what would happen if we have fractions that we want to add that are algebraic fractions. I'm going to do this in 2 steps, just like I did with multiplication and reducing. I'm going to start with monomials, and then we'll go on to polynomials. So suppose I gave you this, 5 over 6x minus 3 over 2x squared. What if I asked, I'm going to do it very slowly, and then I'll go back and I'll show you a little bit quicker way of doing it. What if I want to, obviously this is subtract these two fractions. They don't have the same common denominator, so I have to find a common denominator. Well, if I think about it, this really is 2 times 3 times x, and this is 2 times x times x. Again, I'm going to do this a little quicker in a minute, and I'll redo it a quicker way. Remember what I told you to do. Start with your first fraction, denominator, and circle everything, every factor, in this case, each one, 2, 3, and x, are all factors, they're all being multiplied. We circle them all. Go to your second fraction. We've already circled. I'll just put a check mark there. I've already circled the 2. I've already circled the x. But now there's a second x. I only had one x over here. I had to circle the second one. Each one only represents or stands for 1. Multiply all those things that you circled together. 2 times 3 is 6. X times x is x squared. So multiplying all the different factors that you see, not the repeated ones, but the original ones, the ones that we circled, gives us 6x squared. Okay, so the first step is to find the least common denominator. The second step is to rename your fractions. Remember, we've changed our denominators to the least common denominator. If we changed our denominators, we have to change the numerators. Whatever we multiply the denominator by, we have to multiply the numerator by the same. And we do that by dividing the original denominator into the common denominator. So 6 into 6 cancels out. X into x squared gives me x. I'm putting this number, this answer over here on the side. I got an x when I divided 6x into 6x squared. So I have to take this x and multiply by the numerator 5, which gives me 5x. Again, I do the same thing over here. My original denominator is 2x squared. I'm going to divide it into the 6x squared. 2 into 6 is going to give me 3. X squared into x squared cancels out. In other words, to go from 2x squared to 6x squared, I had to multiply by 3. Therefore, I have to multiply the numerator by 3 as well, and 3 times 3 gives me 9. I now have a common denominator. I combine my numerators by adding or subtracting the numerators. In this case, there's no like term, so I just do 5x minus 9 over 6x squared. And there's no way of reducing it. This would be your answer. Let me go over and tell you how you could have found this common denominator a little quicker when your denominators are monomials. You look first at the numbers, the coefficients, 6 and 2, and think of this. You can usually do in your head. What is the common denominator between 6 and 2? What number do both 6 and 2 divide into? We're not looking for a factor, we're looking for the common divisor. So between 6 and 2, obviously that would be the 6. When it comes to the variables, just pick the variable that you see with its highest exponent. There's an x here and an x squared here, so the common denominator has to have the x squared. Remember, it's not a factor. You don't look for the lower one, you look for the higher one. If you see an x any place, just pick the highest exponent of that you see. That will give you your common denominator. Again, Once you have your common denominator as 6x squared, you can then rename your fractions. Okay, let me give you one to try on your own. Okay. So we have 5 over 8x plus 1 over x minus 1 over 4. While I'm starting to take attendance, I want you to work on finding the common denominator. I'm going to be taking attendance and you find the common denominator. We're going to look at the different numbers. These are all monomials. I'm not going to go into the polynomial method today because I want to do some review. So I'm just going to be dealing, we're going to do this one, we're going to do one more, and then we're going to go into our review. I look at first the coefficients. There's an 8 here. Obviously, this is a 1 and a 4. The common denominator of those 4 numbers, 8, 1, and 4, is obviously 8. Then I look at the letters. Remember, the variables are really the easier part. I have an x here, and so I have an x. Doesn't matter if I have them in all of them. As long as I have an x in one of them, I have to use an x. Now I look, what is the highest exponent? Obviously, there's only plain x's, so the highest exponent is x, just next to the 1. My common denominator then becomes 8x. Remember, with a common denominator, we're looking for something that each denominator can divide into. So now we found our LCD. We now want to rename our fractions by dividing. Now I'm going to finish up the problem. We're going to divide 8x into 8x. That gives me 1. So I have to multiply this 5 by 1, and that leaves it 5. Or think about it this way. I didn't change the denominator. I don't have to change the numerator. This is 8x in the denominator, so the 5 stays in the numerator. Then I go to my second fraction. Here's an x. I divided the x into the 8x. That gives me an 8. I'm just putting it over here. This is just for my own. Let me just circle it just to keep track. This is what I multiplied. I multiplied this x by 8 to get 8x. So I've got to multiply the numerator by 8 as well. This numerator is going to turn out to be 8. And finally, I go to this denominator fraction. This is a 4. 4 into 8 is 2. And there's the x, there's no x, so it gives me 2x. 4 into 8x gives me 2x. I have to multiply this one by 2x. That gives me a 2x. Let me just, these were just helpers. We don't need them anymore. We now have the right common denominator. We're going to now combine the numerators. This is a 5 plus an 8, which is 13. 13 minus 2x is this numerator, because the 2x is not like terms. The 5 and the 8 are like terms, but the 2x has to be separate, and it's all over 8x. There is no way of factoring. Remember, now the numerator is a polynomial. It's 2 terms. So if I wanted to reduce it, I'd have to factor it. And this is not factorable, so there's nothing that I can cancel out. And this would be my answer to that fraction. See if I can give you one to try on your own completely and see if you can get the right answer. Here's one for you to try. Okay, what if I gave you something like this to combine? Let me just start you off. Anytime you have a whole number and you have other things in the expression that are fractions, put that over one. I think we've mentioned this before. Make every single thing a fraction, okay? So I would going to give you a few minutes to try this and see if you could combine it to a single fraction. Is find the common denominator. And the numbers I see are just 1, and these are also 1. So 1 is the common denominator of the numbers. In terms of the letters, I have an x and an x squared. Since the larger exponent is the 2, my common denominator is going to be 1x squared or just plain x squared. So now I'm going to rewrite each of these fractions with exponent, with the common denominator x squared. So first I go 1 into x squared. That gives me x squared. So I have to multiply this 2 by x squared. So the first fraction becomes 2x squared over x squared. Then I divide the x into the x squared. It gives me an x. So I have to multiply this 3 by x, which gives me 3x. And over here I have x squared, and x squared cancels out, leaves me just 1, so 1 times 5 is 5. In other words, I didn't change the denominator, so I'm not changing the numerator. Now, if you notice, we now want to combine the numerators. We leave the denominator x squared, and they're no like terms, so I just write 2x squared plus 3x minus 5. And that would be your answer, 2x squared plus 3x minus 5 all over x squared. Now, I think it was Nikisha, I just want to make a comment. What you wrote was completely correct, but if you were doing it that way, if you're using a slash instead of a line under it, then you really should put everything, the 2x squared plus 3x minus 5 in a parentheses, because otherwise it looks like the only thing that's over the x squared is this 5, the way you printed it. I understood what you meant, but the correct way, you don't have to do it when you can write your fraction line long enough that you would see what's on top. But if you're using that slash, then put everything that's in the numerator in one parentheses, and the same thing in the denominator. In this case, it's only one term, it doesn't matter, but if there were more than one term, you would have to put that in parentheses as well, in order for everybody to realize that what you want to be the numerator and what you want to be the denominator. Okay, but this was your answer. We will continue with this on Thursday. We'll complete adding and subtracting of fractions, and we will go on to solving equations that have fractions in them. Just again, as a reminder, first of all, if you did not do the Delta Math second test, it really was due on Friday, but there is a late date, so you can still do it. There is going to be a reduction in the value in the test. If you have a good reason for not having been able to do it on time, then email me your excuse, and if I feel it's valid, I will then give you back the full credit for the test. But this is only for doing it this week. Afterwards, it's just, if you're not keeping up with the work, it really is going to affect your mark. Don't forget that I gave you also this practice midterm. If you want to do it a second time for any reason, if you either got shut out because your internet went off or something, just email me and I can reset it so you can start the test again. This is a practice test, even though it's a test that's going to be marked and you're being given a mark for it as a class mark. It's really a practice for the midterm. You really have to know how to handle tests on Blackboard, because that's the way your midterm is going to be given and your final exam as well. And having said that, I would like to now go and review how to solve questions where they're asking you to find the equation of a line. There are a number of these. There's always a number of these on the midterm and on the final. And I would like to go through those type of questions. So that if you had any trouble with those are the type you know that you have to study. One question, these are not the exact questions on that practice midterm, they're similar. One question says, find the equation of the line through the pair of points. And the 2 points they're giving us is -7 and -6, and -4 and 9. Now, let's just go through the steps again. We want to write the equation of the line. The equation of the line is the format y equals mx plus b. This is what we call the slope-intercept form of the line. And in order to do it, we need two things. We need to find the slope of the line, and we have to find the y-intercept. The b is where it's crossing the y-axis. And we always start by finding the slope. Now, if you remember, there's a formula for the slope that goes y2 minus y1 over x2 minus x1. And just pick one of your points to be your x1, y1, and that makes the second point, the x2 minus and the y2, and just put in the numbers. Y2 is 9 minus -6, that's y1, over x2 -4 minus -7. Remember, when you have, just be careful with your numbers, be careful with your arithmetic. A minus and a minus becomes a plus, so 9 plus 6 becomes 15. And this also becomes a plus, -7 plus -4 plus 7 becomes +3. And therefore, our slope is 15 over 3, which can be reduced to 5. So now we know that our equation is going to be y equals mx. This is my m. 5x plus b. We're still missing the b, the y-intercept. And neither of these points are the y-intercepts, because the y-intercept is where the x is 0. If the x is 0, then the y value is the y-intercept. But neither of these points are on the y-axis. So what I do is I just take either one of the points. This looks a little bit easier to work with, so I'm going to use that one, and stick it into the equation. That means in place of the y, I'm going to put a 9, and in place of the x, I'm going to put a -4. In order for a point to be on a line, it has to fit into the equation of the line. So this gives me 9 equals 5 times -4 plus b. And this will enable us to solve this equation. So this will be 9 equals 5 times -4 is -20 plus b. Bring the 20 to the other side. That gives us 29 equals b. And therefore, my equation then becomes y equals 5x plus 29. This is the line in what we call the slope-intercept form. So let's just review the steps again. We have the 2 points. We can use the slope formula to find the slope, and then take either one of the points. It doesn't matter. You'll get the same answer, whichever one you take. Stick it into the y equals mx plus b equation, and that'll give you what the b is. Does anybody have any questions about doing this type of question? Okay, so that's one type of question. You're given 2 points, and you're asked to find this equation of the line. Another type of question reads like this. Find the equation of the line where that's described. It goes through the point 2, 4. So we want to write the equation of the line that's on 2, 4, and is parallel to y equals -4 over 9 x plus 1. So that's the other type, the other type of questions we could have that have to do with writing equations of lines, where we give a description where the line is either parallel to a given line or perpendicular. Let's just remember, if the lines are parallel, then the slopes are equal. If the lines are perpendicular, the slopes are what we call opposite reciprocal. And when we want to write the equation of a line, the first thing we're interested in finding is its slope. Let's call this line number A. Number A is the line that they gave us the equation of. Line number B is the line that I want to write the equation of that's in this description. My line is going to be y equals mx plus b. I have to figure out what the m and what the b are going to be. So in line number B, the first thing I can talk about is the slope. A and B are parallel lines. Parallel lines mean they have the same slope. So the slope in line A is the number in front of the x, which is -4/9. The slope in line B is also going to be -4/9. In other words, my line, the line that I'm trying to write the equation of, is y equals -4/9 x plus b. It's going to have the same slope. What's going to be different is the y-intercept. They don't go through the same place, because if they go through the same place, they're the same line. They're not the same line. They are different lines. So we now have to figure out what the b is. And that's where knowing a point on the line helps us. Since I know that the point 24 is on the line, I can stick in for the x2 and for the y4. So this will give me 4 equals -4/9 times 2 plus b. Now, here we're running into fractions. So I remember what I just told you before. When you have some fractions and some whole numbers, put all your whole numbers over 1. So then you can see everything in terms of fractions, and it's easy to keep track as to what's in your numerator and what's in your denominator. So this becomes 4/1. Okay, now multiplying -4/9 times 2/1. Nothing cross cancels, so I just multiply the two numerators together, which is -8/9, and that gives me b/1. And the easiest way to do this is to multiply. I think you're going to remember that we did this. Multiply by a common denominator. We just figured out how to find a common denominator. We have 1, a 9, and a 1. Our common denominator is 9. Multiply the whole fraction, both sides of your equation, by the common denominator, which is 9/1. Okay, so we're going to get 9/1 times 4/1 equals 9/1 times -8/9 plus 9/1 times b/1. Now I'm going to have to go over here to this. I'm going to go over here because I'm getting a little too low. 9/1 and 4/1, nothing from the bottom. There's no cross canceling, so I just multiply the numerators together, which is 36/1. Okay, then I go to the next one. Oh, there's a 9 in the numerator. Remember, we put a 1 where something cancels out. The 9 in the denominator. And all I'm left with is 1 times -8, which is -8 over 1. And finally, here nothing cancels out, and I'm left with plus 9b over 1. Now, since everything is over 1, we could just write it 36 equals -8 plus 9b. We don't need those ones anymore. We then bring the 8 to the other side. And we get 36 plus 8, which is 44, equals 9b. And if I divide by 9, my b comes out to be 44 over 9. So if I look at this, the final answer becomes y equals -4 over 9x plus 44 over 9. And that's your answer in y equals mx plus b form. What makes this a harder question is simply the arithmetic. It's not the concept. It's the idea that sometimes you end up with a lot of fractions. Again, you can use your calculator. These are number fractions, so you could have use your calculator. For example, you could have added 8 ninths to both sides and used your calculator to figure it out that way. It would have done it for you. If anybody has any questions about how to use their calculator properly, I can do that with you. Again, the only difference between a question where it says parallel lines and where it says perpendicular lines, I want to spend some time answering any questions, would be that when you got to your second line, if the lines are perpendicular, for example, if here the slope was -4 over 9, they both have slopes of -4 over 9. Whereas if the lines were perpendicular, then the new line would have to have a slope of 9 over 4. You would have to flip it and change its sign. If it's originally negative, it becomes positive. If it's originally positive, it becomes negative. So that's the only difference between when lines are parallel and when they're perpendicular. The other type of question that might be is if you talk about lines that are parallel to the axes. Let me just erase this and make one other comment. Let's say I give you a point like this, 4, -2. I'm just going to draw this. Here's 4, -2. 1, 2, 3, 4, 1, 2. Here's the point 4, -2. The two special lines that we sometimes talk about are what we call the vertical line and the horizontal line. A horizontal line is a line that's parallel to the x-axis. The equation of a horizontal line is always y equal a number. There's no x in the equation, just y. In this case, your y is -2. Your equation would then be y equals -2. Notice in this case, the slope is equal to 0. A horizontal line has a 0 slope. Again, and it's y equal to whatever the y value is. A vertical line, and it goes straight up and down like that, has an equation x equals a number, and the number in this case, of course, is 4. Whatever the x of the point is, that's x equal to 4. In this case, the slope is undefined, we sometimes say, or it doesn't exist. either way you mention it, there is this line, a vertical line doesn't have the slope. It's not, the slope is zero. The zero is a number. It has no number slope. It's got a zero in the denominator and therefore it's undefined. So those are the two special lines that we sometimes come across. Okay, I am now ready for you to ask me. Yes, I can, Diamond. I'm going to